Hello, young grasshoppers. So today we worked on classifying shapes and then also now working on mineral classification. Now, I gave you some minerals and you came up with your own way to classify them. However, there are ways that scientists classify minerals, and they do that using a dichotomous key, just like we did in class, but it's based on some properties that you might not realize. The first thing we need to know is what is a mineral. So, you should write this down for the definition, but here are parts of the definition of a mineral. There are 4 parts. First of all, it is naturally forming. It forms in nature. Second, it's a solid. 3, it has a definite chemical makeup. So that means that it has basically a chemical formula, and we'll talk more about that, but it basically means that it's definite and it doesn't change around. So that means that you would have to cause like a chemical reaction to change it, and then it would no longer be a mineral. And then finally, it has a crystal structure. Now, we think of crystals as these beautiful things that are shiny and wonderful, but really crystal means a repeating pattern in the atoms or molecules that make up the mineral. So we'll talk more about what that looks like, but just know that these are the 4 parts. If you need to pause the video to write it down, go ahead and do so. So, let's talk about color. The very first thing that a lot of you looked for when you were classifying your minerals was what color is it? And color is not always a good indicator. Okay? First of all, tiny amounts of elements in a mineral can change the color. Defects in the crystal structure can change the color, and slightly different conditions when the mineral was formed can change the color. So when we're trying to identify a mineral, color is not always a good indicator of that, even though it is the most obvious. These, for example, are all quartz. There's a type of mineral called quartz, and all of these versions are quartz. But if you look just at the color, you might be confused. You might think that they were different minerals based on that. So that's why color is not a good indicator. Okay? So let's talk about streak. Streak is the color left behind when you grind a mineral against a streak plate. Now, you should be writing this down on your notes, your note-taking guide while we go. There's boxes for the different properties. So streak is when you actually grind it. So some of you did that today in class with one of the minerals. You actually rubbed it against your paper, and that's sort of the same thing. Okay, a streak plate is made of porcelain. So this is an example. A red-brown streak, and quartz always leaves a white streak. So no matter what color it is, it will always leave a white streak. So that's why streak is better than color. Okay, because remember, color, there's a whole bunch of things that can affect color, but streak will stay the same for a certain mineral. Luster. Luster is a fancy word to say how much light is reflected. So if it's really shiny, like a metal, we use the word metallic. If it's not shiny, then we use the word non-metallic. And there are lots of different non-metallics. Okay, but let's look at metallic first. Galena is a mineral that's an example of a metallic. Notice how shiny and silvery it looks. Okay, just like a metal. Non-metallic are all different ones. Really, I want you to focus on just non-metallic means not shiny, but I wanted to show you. There's adamantine, which has the look of sparkly diamond. Okay, like that. That's an example. That's the mineral, adamantine. It's not diamond, but it looks like it. Okay. Glassy or vitreous. Okay, so we call something glassy. Polysite is a glassy mineral. Looks vitreous is the other word. Pearly, having the iridescent look of mother of pearl. So does it look pearly? See how it's sort of like shiny yet not shiny at the same time? I don't know how to describe it. This mineral is stellarite. And earthy. So kind of, this is kaolinite, but basically it looks sort of dull. Okay, you have one of the minerals in your bucket, in your bag today that looks sort of dull. Okay, so basically when we look at a dichotomous key for classifying minerals, one of the choices is what's its luster, metallic or non-metallic. Cleavage, now that kind of makes people giggle sometimes, but cleavage is the tendency of a mineral to break along flat surfaces. And sometimes it almost even looks like it was cut that way, even though it wasn't cut. Okay, so if you need to stop the video to write that down, go ahead and do so. That's why it's a video. But let's look at cleavage. Here's an example. This mineral, it looks like it was almost cut in these flat planes, but it wasn't. It breaks along flat surfaces because the bonds are less strong in some directions than others. So let's look at that. This is the crystal structure, and so these are carbon atoms bonded to each other, and there are layers of carbon atoms bonded to each other, but the bonds between the layers aren't that strong. So when that happens, often the mineral will break along the weak bonds, which gives it sort of a flat, like a cut look. Okay? Fracture. Fracture is the opposite of cleavage. Fracture is when it breaks in jagged, irregular pieces. Okay, so an example here is quartz. When quartz gets broken, if you hit it with a hammer, it breaks into these irregular surfaces because there are no weak bonds. And if there are weak bonds, they're not all going in the same direction. So fracture and cleavage are the opposite of each other. Okay? Then finally, there's hardness. Now, there's a certain scale called the Mohs hardness scale. And it tells you basically what can scratch a mineral or what the mineral itself can scratch. And it uses 10 well-known minerals as the scale. So if it has a hardness of 1, it has the same hardness as the mineral talc. If it has the hardness of 2, gypsum, 3, calcite, all the way up to the hardest mineral, which is diamond. Diamond is very, very hard. Okay? You do not ever need to memorize the names of these, but you do need to know how to use a hardness scale. And Mohs hardness scale is just named after a scientist. Mohs was his last name. So if a fingernail can scratch the mineral, then it's about a 2.5. If a mineral can scratch a penny, then it's about a 3, okay, or harder than a 3. If a mineral can scratch glass, that means it's harder than a 5.5 or 6. And if a mineral can scratch a steel, that means it's harder than 6.5. But it works the opposite way too. If a steel nail can scratch a mineral, then you know the steel nail is harder, and so therefore you know that the mineral has less than 6.5. Okay? So this here is the hardness of these objects. Okay, so if it can scratch the mineral with those objects, then you know that the mineral is softer or less hard than those objects. Okay? Let's look at the Mohs hardness scale. Oops. So looking at the Mohs hardness scale, you can see different things. So a steel file or steel nail has a hardness of 6.5. You can scratch apatite with a steel nail because apatite has a hardness of 5. Okay? So really it's about relating the hardness of the object with the hardness of the mineral and figuring out where it fits. Okay? All right. Have a great day.